You understand it in basic physics. You can't add anything to the universe, and you can't take anything from it. That's the first law of thermodynamics. Nothing, nothing. I mean the slightest particle. The antineutrino was a major mystery to them, and the neutrino was a major mystery to them. And they had to find the neutrino, and they did. In 1937, there was a major crisis in physics because they couldn't find the neutrino, but then they found the neutrino because it all had to balance out. You can't add anything, you can't subtract anything. Remember that. You can't add anything to the universe, you can't subtract anything to the universe. Otherwise, you have to reconstruct the whole universe. Got the idea? All right, watch this. And these are technically justified from the technical literature. This cosmological constant is critically fine-tuned to 1 part in 10 to the minus 120th. David Bassett, can you very quickly come up here? He's a mathematician, and explain to us how precise that refinement is, how big that number is, but of course it's to the minus here, which shows it has to be refined to such a dimension, it is astounding. Okay, the density / mass of the entire universe. Now, as he's coming, every year our telescopes get more powerful and they're able to say, okay, we have 100 million more galaxies than we thought we had last year. But the ratio of those galaxies and the subatomic particles remains the same, so the principle, mathematical principle, stands. So David, here, if the universe is so acutely fine tuned to 1 part in 10 to the minus 120th power, explain that number to us.
Okay. If it was 10 to the positive 120th, that'd be a 1 with 120 zeros after it. Just kind of imagine that. Earlier you were saying 100 million, billion, 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 and a billion is 10 to the 9th. It's 1 with 9 zeros. We're talking 10 with 120, or 1 with 120 zeros after it. But because it's a negative exponent, we have to divide that number into 1. So 1 divided by a 1 with 120 zeros after it is the number we're talking about.
Yes.
Basically, we're just barely above 0.
Which means that it is so fine-tuned that you can't erase or lower it or the whole thing collapses, right?
Well, mathematicians say that anything over 10 to the 50th will not happen by chance.
Got it?
Will not happen by chance.
Anything beyond 10 to the 50th has no chance of happening. Yeah, okay, you might need that again.
Thank you.
Okay, thank you. All right, now let's put this into a perspective that I think you'll appreciate. In a technical journal, an article was released, and it was titled Thunderbolt from Heaven. And that's where they calculated this 1 part in 10 to the minus 120th. Now let's apply this. There are 10 to the 82nd protons in the universe. And again, if the universe is bigger than we have now calculated, the ratios still remain the same, so the math holds up. There are 10 to the 82nd protons in the universe. The critical value of the initial density is fine-tuned to 10 to the 62nd from supernovae observations. So that's a difference of 10 to the 20th protons. Now, are you still with me? If we change the universe 10 to the 20th protons, it wouldn't work. That's the whole point of this. Now, as David explained, 1 followed by so many zeros. The number is pretty big when you get 10 to the 20th, 10 to the 30th. But when you get to 10 to the 40th, 10 to the 50th, it goes beyond the chance of it occurring. 10 to the 20th, this difference of the protons in the universe and the critical value of the density, fine-tuned, is 10 to the 20th protons. That's the number of protons in a grain of sand, which means that if we increased the universe, excuse me and thank you, if we increase the universe by a grain of sand, we would have to simultaneously reconstruct the rest of the universe to match it. Are you with me? That's the bottom line of all we've been talking about. If we added a grain of sand to the universe, we would have to reconstruct the rest of the universe to match it. Or if we took a grain of sand from the universe, we would have to reconstruct the entire universe to match it. Seems like I remember in Matthew chapter 14 and again in Matthew chapter 16, Jesus was preaching on the hillside. And the crowd got hungry. In fact, the disciples came and said, Master, we didn't know you were going to be talking this long. The crowd's hungry. What shall we do? Jesus said, feed them. And they said, 100 pennyworth would not be enough. They had already calculated. Do you know how much? I was in North Carolina and I was reading some material. Someone calculated 100 pennyworth, 200 pennyworth. That's 125 boxcars of bread. Engineer, 125 boxcars of bread to feed that crowd. Because there were 5,000 men plus women and children. Jesus said, feed them. And they said, it would take 200 pennyworth to feed them. They already calculated it. And he said, does anybody here have any food? They had already understood the problem. They were good apostles. They said, there's one little old kid. He was the only one who expected you to preach this long. Oh, one little kid, and he's got 5 little barley loaves and 2 little fishes. Little things. Jesus said, bring him to me. They brought him. I'm so glad that little boy was willing to give Jesus his lunch. If he hadn't, a major statement in astrophysics would not have been made. Jesus took that little boy's lunch. He took a loaf. What did he do with it? A loaf is just a little old biscuit. What did he do with it? He broke it. Now there were how many? Then he broke those. How many were there? 4. He fed 15,000 plus people with that bread and the fishes, and there were 12 baskets full to the brim left over. Class, do you understand? All the way from Pennsylvania to Glen Rose, I think you've got this. Every time he broke that little barley loaf and doubled it, he simultaneously reconstructed the whole universe. Wow is right. Otherwise, it would have fallen apart. Oh, by the way, before he did that, a simple statement is made. He looked up to heaven. He knew what he was going to do. Every time he broke a little barley loaf and doubled it, we know of at least 800 parameters where it's been measured. They're related to each other. Our Creator is awesome. He is absolutely awesome. Okay, we're almost out of time. Can you wait a little longer? Yes. Okay. So that's what this means. And the ratios, not only each ratio, but the ratios to each other. New Scientist, a scientific publication, presented an article to get one additional universe. Now, the secularists say, okay, we know how this universe is so fine-tuned. There have to be other universes, and we just happen to live in the one that's just right. There have to be, well, where are these? Well, I don't know, but there have to be. Otherwise, you have to You have to admit there's a creator. Well, yes, that's correct. So watch closely. How many universes would there have to be? They first started with, well, you'd have to have 10 to the 50th power of universes to get one this refined. But then they started recalculating and realizing for every different parameter they found, and there are now over 800 different parameters that they have cataloged. Each new one has to be calculated into the possibility of another universe not having this, but they've never seen one additional universe. So all of that's speculation. But let me show you how many universes. It would be 10 to the power of 10 to the power of 10 million universes. 10 to the power of 10 to the power of 10 million universes. David Bassett, we need you again.
Every time we say 10 to the power of 10, we're raising 10 as an exponent that number of times. So we're actually, it's going to be just multiplication upon multiplication upon multiplication over and over again by powers of 10. So for instance, like 10 to the second power is going to be 10 to the, because the fourth power is a much bigger number than 10 to the second power. Here we're talking about enormously huge numbers that we can't even conceive.
Correct. We can calculate them, but we can't conceive them.
Right, so we're doing exponents upon exponents upon exponents. It's not just a simple matter of addition. It's a multiplication of a multiplication of a multiplication. That's what we're talking about.
That's what we needed to know. Okay, thank you. Thank you so much.